on the side. It's a flimsy part because it's just a sheet metal. So to make it into a solid part, we have to stiffen the inside of that with stiffness so that it's a rigid component. It's just flimsy, and we make it rigid by applying stiffness. And stiffness are also, yes, so those are more like your struts to make sure that the structure is solid when we assemble them. So if I may quickly explain, so the line basically starts almost in the center. I will show you when we get there. We receive about 140 tons of steel from local Columbus, but via mixed steel. And that's the steel that we put through the profile machines, and then we form it into different shapes. Typically, there's another one right at the bottom. That's the corrugation, because it's corrugated sheeting, and that we use on the roof. When we are done this side, then we'll move over to the plasma cutter. That's where basically we'll start to profile and cut some of the items that we need. On the letterboard, which is the one that I spoke about, we cut windows for the screen that will be indicating to customers that are standing outside the train whether we are going to Umlazi or Naledi or where we are going. So that's why it's called a letterboard. If you look at the one behind the stiffness, which is the most integral part for the underframe, because that's the one that basically holds the underframe together of each and every car. We have to cut round holes. That's where we'll weld onto carbon steel, and that happens basically in the plasma cutter. So the process starts first with profiling. We make all the shapes, and then after that we cut with the plasma cutter all the shapes that we need in our manufacturing process. That's the process where we initially do the first fabrication of the train. Thank you. If you may proceed. Yes, so what you see all the time in the blue trolleys, those are the different profiles that we build for the train. And then on my right-hand side, as I indicated, that's typically of a letterboard. You'll see that we've already cut some of them, and inside the machine, we are already cutting the next car to prepare later on for the assembly.
So this is the front of the train?
These are just this for the sides components. When we come forward, then you'll start to see how they all add up together. So if I may, the corrugated sheeting, what I showed you earlier on, we can only do a width of about 600 millimeters, but we need big parts. So this machine here on the right hand side, that's what we call a seam welder. So we take all the small components, we seam weld it to make a big part. And just ahead of us, that's a typical completed part on my right hand side of a complete roof sheet that will be used to build the roof. So we take it from small component, seam weld it to big components.
So that's a roof?
That is part of the roof that is not yet completed. I will show you a roof when it's completed.
And then this, it's parts for the roof?
Yes, that's correct. So those are the single sheets. If we may quickly stand here, yes. So we take the small sheets, we put it in a seam welder, then we weld it together to form one big sheet. Because you can't profile corrugated sheet in big sizes. Otherwise, then you won't get the geometry of the components correct. So on my left-hand side, this is where I had referred to where we start the line. You'll see the blue machines. That's basically what does the profiles. In the beginning of the station, you will see it's a sheet. It's a flat sheet metal, and all those blue tools, they will form it in whichever shape that we want.
So does it heat it up to bend it, or it just uses pressure?
It just uses pressure. This is all cold forming. We don't do any hot forming in the plant. So this is a typical coil. As it arrives, we have different sizes because the sizes, they also determine the type of profile that we can do. So this is then loaded. We can't see inside, but I can quickly show you here. Please follow me. So typically in there, that's the roll. So that roll, we unroll it. If you look at the bottom, that's the flat sheet. As the sheet progresses into the blue machines, it changes the shape into this shape. That's correct. And we've got different nine types of shapes that we do. Yes, this is the thickest we can do. This is 6 millimeter. The reason why it is the thickest, like I said, it is the one that holds the integrity on the underframe. When we get to the underframe, I will explain why this is important, that is thick material, because this is basically holding the base of the train, and this is to ensure for safety of the train.
So it's shaped.
No, this is one sheet. It's not pressed together. It's one roll of 5 millimeter, and then we just roll from it. So we are going to move over onto the right-hand side. You asked me for the roof, then I would love to show you a complete roof when it's built. On the right-hand side, thank you.
Okay.
So we may stay here. So if you remember the big sheets, the corrugated sheet on the other side, this is now where we assemble it together. So we'll take what we call roof side members, we'll take the corrugated sheet, and then we will take all these other small components and weld it together. Why we need all these small components is because we assemble components on top of the train, so therefore we need to be able to mount them. So these are all mounting brackets.
So that's the thing that the electricity stuff is attached to on the roof.
Absolutely, that is correct. So these brackets, that way we will mount all our pantographs as well as the HVAC unit. Thank you. So earlier on, I spoke about stiffness. So typically, we'll take the letterboard from the station, from the plasma station, then we'll store it in here, then we'll bring all the stiffness, then we'll weld here. This is the only two stations, this one and the one next door, where we have robots, simply because we have to do over 5,000 spots weld. If you ask a human being to do 5,000 spots weld, they will never get the geometry correctly at all times. So that's why these are only two stations that are automated. The rest is all welded manual.
So how did they do it in the old days before robots?
So, very good question. So before the robots, they use feeler gauges. They use also clamps to be able to get the geometry correct. The problem with that, then we won't be the fastest plant. Currently, we are the fastest plant in terms of electrical multiple units, because we are able to do 2 cars per day. Most plants, they do 1 to 1.5. So in order for us to be able to have that competitive edge, we had to install these robots, because that was the biggest bottleneck. When we started with only 3 trains a year, and now we've ramped that up to 64 trains a year. Then if we continue on my right-hand side, that is basically where we will do the side wall, which is the side of a coach. And then typically what will happen, this will be the panels that we'll build on the sub-assembly side. We will then have the door frames, and then we'll take the letterboard. So on the other stations where I showed you the letterboard, where you put the stiffness, once it's completed, it will be loaded into this station. So in this station, basically, it's one coach, because you need a sidewall on either side of the coach. So that's why you see the 2 stations. That's the window, and that's the doors. So you'll have, yes, that's the bottom, and that's the top. Thank you. So all the components that we fit in the mainstream, which is the main line, they are built this side. We only use stainless steel and carbon steel. Carbon steel, which is what we have here on the left, we use it for the underframe, because that's where we also have to mount the bogies. We don't have one structure similar to the older trains, because we want to have flexibility and torsional stress of the cars. So we have about 2 pieces of that, and then we fit it with sheet metal in between. When we go to the other side, I will show you how a typical underframe looks like, and then also show you the 5 millimeter material that we discussed on why it's important for the train.
Where are the people that are working on all these stations?
So there are people that are working in the stations. The reason why now you wouldn't see them is probably because they are on a break, but they are here.
Okay.
Yes. So we have different shifts. No, we don't remove people. They went for lunch, madam. Thank you. Yes, I was going to explain. So we have 3 different types of shifts. We have shops that work 3 shifts, we have areas that work 2 shifts and also 1 shift to balance the line. We need to make sure that we do 2 cars per day. So we have faster stations and we have slower stations. So that's why we have a differentiation of the shifts. They don't all go on the same time for lunch, they go different times.
All right. So
Yes.
if there's people at a given time,
How many people at a given time in the factory? In the morning shift, we have about 260. The afternoon also we have about 260, and the night shift we only have 50 people. The reason being that this station, as well as the robots, are our bottleneck. We need about 26 hours to be able to rotate 2 cars. That's why they are working over a 24-hour shift pattern.
so if you've got 1,200 employees, how come you've only got 400 in the plant?
Okay, so we have what we call direct employees. Then we also have the services side. Sis Vuiswa, who spoke to you, runs the services side. So we have some of them there. We have people also in 4 different depots: Durban, Cape Town, Gauteng North and Gauteng South. And then after that, we have all the supporting functions that ensure that the people that are touching the car and doing value-adding work, they have all the resources that they need.
So it's 1,200 in the whole ecosystem.
That's correct. That's 1,200, not necessarily all of them in the plant. That's correct. So Minister, if we look on the left-hand side, this is all the sub-assemblies that I spoke about earlier on. All these sub-assemblies, then they will be built into the main line. So this is typically what a door frame looks like, and then this is also loaded on the main line.
This is the thing that slides.
No, this is not the thing that slides. The one that slides is on the doors itself. This is further down the line. This is basically the opening. Yes. And then, so these components, we use them on the underframe. When we go on the other side, I will show you exactly where on the underframe we fit them. If you remember, I said we use 2 carbon steel, and in the center of the underframe, these are the panels that are going in the center of the underframe.
Okay.
And then on my right-hand side here, this is a typical, what we call a side panel. So if you take 4 of these, you take 3 door frames, you take the letterboard, that makes up a side wall.
Okay. Okay.
So now we've seen the side walls.
You make everything here.
Yes, we make everything here. We don't, we make everything here. There are buy components that we buy from the local suppliers, as we indicated. So anything that is generally in your blue bins, we get them as buy parts from the local suppliers. But in terms of the manufacturing, we manufacture everything here. Yes, that's correct. So this is another typical side wall. We've got one with a single window, and then we also have the one with a double window.
Oh, okay. And those round things we are going to weld onto those.
Yes, that's correct. Those round holes, what you see at the bottom, we'll use them to weld onto the underframe to make up an assembly. So, yes, this is what we call an end frame. So I've shown you the roof. I've shown you the 2 sides. Now you need an end frame on either side of the coach to complete a coach. So typically this is what we call an end frame. Please follow me. Okay, so now we come to what we refer to as cathedral. So all those sub-assemblies, what you've seen in the previous shop, we now assemble them together. This is the first level of assembly. We'll have the orange framing gates. They will hold the side walls. And then we'll have the 2 end frames in front and at the back. We'll have the underframe, and then we'll have the roof. So this is a very crucial stage in the process, because this is where we need to get the geometry correct of the coach. We need to make sure that inside you will see cross braces. This is to ensure that the car is parallel, the car is not skewed, and also that the car is balanced in terms of leveling as well. So this is all manual welded. There will be people then that weld both on the inside and the outside of the car to ensure that the geometry is correct.
Excellent.
So we have both two lines, left and right hand side. We do exactly the same item.
These ones are actually welding.
Yes, I would love to show you. Give me a second. So we have not seen the underframe up to so far. We've seen the roof, we've seen the sidewall, we've seen the end frames. This is where they complete the underframe. So the underframe has got a rotating jig because there is welding that we need to do underneath as well as welding that we need to do on top. This is also to ensure that there is no water that seeps through the car from underneath when it rains. So that's what the colleagues are doing here. When they are completed with the welding, then they will also apply sealant to ensure that the integrity of the car is good. Just hold on. Okay, no, we can go this way. So basically, yes, we're going to walk underneath. The line is identical. We don't allow people to walk on top because what happens on top is only welding. So we will. No, this is the platform. There is actually work taking place on top. And then on the left-hand side and as well as on the right-hand side, there are people welding the components and taking the car from one station to the other. Yes. So if you notice, we have a rail here in the center. We used to have one line. When we started, we could only build max up to 25 trains a year. In order for us to ramp up, we had to split the line from one line into two lines. So that's part of the CAPEX project that we did to ensure that we increase the capacity of the plant to reach 64 trains. So that's why we have two lines. So this is just simply a working platform on top. We've got activities that are taking place on top. 90% of what happens on top is only welding by employees. And hence, we don't allow people to go there because then we're going to impact your eyes. Just watch out. So I quickly want to stop here and then I take you through the underframe because we could not see the full process of it. So this is the side seal that we saw, the 6mm material. Those round holes that you saw us punching in the first stations, those are used for welding. Then what we do then, we'll add all the sheet metals in between where there was no sheet metals, and we do all of this manual welding. So you'll have this carbon steel, which is built by Alstom Ubunye, which is around 10 kilometers from here, but still in Niger, and then they will supply that to us. So we have one in front of a coach and one at the back of the coach, and that's where you mount the bogies. And then you asked me earlier on the panels, on the other side, what are the panels used for? So if you quickly move forward, then you'll see the panels. We start to feed them here in between. So these are all those panels that you saw on the other side, and we'll weld all of that together. So this is a typical underframe for one coach. So what will happen, we have floorboards that we are going to feed. There's components that we're going to lay inside the car. So everything, single thing in terms of the holes, that's what we're going to mount. And then also the floorboards will fit in between, but that you'll see on the other side. These boards, what you see, are only used for employees so that they don't step and damage the component as the component moves from one station to the other.
So this is two undercarriages?
That's correct. That's two underframe for two coaches. This is our storage area, basically. So beyond this point, we don't have any more welding. So all the welding work is completed by the time we come here. So we will start what we call pre-fitting. What will happen, we'll start to fit the windows, we'll start to fit the HVAC unit on top. You'll see also for the first time we have a platform on top. That means we are able to work on top of a coach, inside the coach as well as underneath. When we come underneath, we start to fit all your pipes and also some of the components that we need to fit underneath the coach. So this is basically what we refer to as pre-fitting. You also asked me the slide. We also installed the slides for the doors because in the next station we fit the doors as well.
So, but you fit the windows here.
Yes, we do fit the windows here. You will see now there's a car there with windows on.
Okay.
So this is one of our employees. She can introduce herself, what she's doing here.
My name is Mrs. Kwichi. I am an artisan. I've started with Gibela from 2018. So I've been with Gibela for close to 7 years now. And I started off as a semi-skilled. I'm currently studying industrial and I'm looking forward to branch out in PME and processing. So one thing I like about Gibela is that there's a lot of roles and departments you can grow into, and I'm grateful for the opportunity because they took me from school. This is my first paycheck or whatever it is. So yeah, thank you so much.
So what do you do now?
I'm currently working in the station at FT1010. I'm a fitter. Mechanical fitter, so I work installing HVACs and the pneumatics as well, installing the boards and the windows as well. Yes.
That's nice. Good to meet you.
Thank you so much for coming to visit us.
Thank you. So as earlier on as I indicated, we'll start then to also fit some of the cables on top of the cars. And then what you
Where are the cables?
So the cables are also manufactured here locally, both at Ubunye and also at Ubumbano. So then they will supply us to us, then we'll start to feed them. And then what you see on the left-hand side, those are the pipes, and the pipes will also start to feed them underneath the car.
What are the pipes for?
Your pipes, you need them for all your air and hydraulics that is used basically on your brake system. So that's what those pipes are there for.
Okay.
So typically this is the last station. You'll see now we have the windows, we have the doors fitted, and then you'll see on top as well our HVAC unit is also fitted on top. And then, yeah, underneath, you'll start to see also some pipes that we fitted. So this car, when we are done, it will get a green sticker, and then it will go next door where we water test and make sure that there is no leakages that goes inside the car. And we water test all our cars 100%.
So the blue, is that a sticker or you paint it?
So the doors, they come already painted. The train itself, we don't do painting here. We do vinyl stickers, and those we apply on the other side. But the doors, it's a by-part, and it came already painted from the supplier, which is a local supplier as well.
Okay.
Yes, the HVAC also comes from a local supplier. It's 100% assembled here locally. We do also 100% testing to ensure that it's functional. Currently, we do have a
100% assembled, not 100% manufactured.
No, 100% assembled as well as manufacturing, because they get the components and some of them they manufacture internally, then they assemble it. So even at the supplier, we don't just push an assembly point of view, we also push that they manufacture the items locally. So there is a level that we are involved also to ensure that they also do manufacturing.
Okay.
So this brings us to the end of this shop. We will exit and then